Hello, this is an additional video that I just wanted to share with you with regards to the basic structurals. So you've done basic forces with me and we've looked at reactions and moment, clockwise movement, anti-clockwise movement. Some of you will recognise this. This was the original homework that I set. There was an issue with the UDL that I corrected. However, I just wanted to bring to your attention the fact that the student book doesn't refer to the full terminology when it comes to structural mechanics. And what I mean by that is, for instance, we would have what the book is saying. We've got reaction right, and then we've got reaction left. Okay, so that's as far as the book goes. So we've got a reaction on the right and reaction on the left. However, when certainly when you get Josh and when you go to the second year with Dr. Mohamed Elflah, and you start learning the structural mechanics and structural analysis, the terminology is kind of cranked up a bit. It gets, they use the proper terminology. So although I'm teaching to the book so that, you can follow along the book saying right reaction equals or the left reaction, what I want to do is just show you what it would look like, what the terminology looks like when using the correct terminology. So we're going to use this example here. Okay, so a few things I want to show you. So first of all, we've got sorry, I've still got the thingy-majiggy on. Let's use that one again. Yeah, that'll do. Okay. Oh, what's going on here? Let's have a tick. Okay. So we've got a vertical force here and here, because if obviously the forces we have on top, the 11 Newton, 6 Newton per meter and 12 Newton, their forces down. So these forces are up, vertical. So we've got VB, vertical force B, vertical force A. So over here, let's put V equals vertical force, which is reaction. So VB equals right reaction. Okay, so that's how the book would say it, and obviously VA would be reaction left. So let's just leave it as VA VB. Also, we've got the moment. Let's choose a different color for moment. Let's go with this one. There we go. So we've got moment B, and then we've got moment A. Okay, so the moment around A or the moment around B. So when we're talking about the reactions, we talk about the turning force. Remember the torque, turning force. They are the moments. Again, moment B, as the book refers to, would be the right reaction again. Can you see what I'm saying? Right reaction, they're using it as just a generic term for everything, but it's not quite the case. So everything on the right, moment B, is anti-clockwise moment, obviously, and then moment A would be clockwise moments. Okay, and then moment B would be, I'm sorry, it's getting a bit confusing, would be negative, and moment A would be positive force. Okay, so looking at this now that you can see the terminology, what's referred to solve this, we would say the following. So let's choose a different color. Let's choose let's go with orange. Why not orange? I'll tell you what, yeah, let's go with the orange. Right. So this is what it would look like. So the sum of forces vertical, so that would be forces A and forces B, they equal the total forces down. So the total forces, the vertical force is a VA plus VB equals 0. They equal the same amount of forces down, so the total sum of forces. So therefore, because, let's put that, so it's 0 and in brackets, because it is equilibrium. Okay, because it's equilibrium. Then we say VA plus VB, okay, equals total sum of forces. And we can say VA plus VB equals 11 newtons plus 24 newtons plus 12 newtons, and that would equal 47 newtons, the total sum of forces. And remember that the 6 newtons, I'm sorry I haven't put the that there is 4 meters, and as I've explained to you, the UDL here, so it says 6 newtons per meter over 4 meters, so that's 6 times 4 is 24 newtons. So the UDL is then disregarded and it's treated as a point load just there through the center. Okay, so we convert the UDL, so it's 6 newtons per meter and there's 4 meters of it, so it's 6 times 4 equals 24 newtons as a point load, and it's through the center. Okay, through the center. So that's where the sorry about this, that's where the 24 newtons comes from in this example just there. Okay, moving on, let's get our colour back. So we've got, now this is where it changes a little bit more. So we've got the total sum of moment around A. So we're looking at the left hand side. So we're looking at the reactions on the left. So the reaction left, or VA, or moment around A. The clockwise moments is the moment around A. Okay, let's put that. The sum of moments around A. All right. And that would look like this. So total sum of moments around A equals 11 newtons times 1 meter plus, don't forget we've converted the UDL into point load, so it is now 24 newtons times 5 meters, because we've got, where the UDL is, it says 4 meters, doesn't it? It says 4 meters just there. Well, from the left around moment A, we've got a 1 meter plus a 2 meter plus half of that 4, because the point load, that 24 Newton point load, is smack in the middle of that 4 meters. So therefore it's 2. So we've got 2 plus 1 is 5, and that's where we get this 5 meter from. And then we've got 12, so we've got plus 12 Newton times 13 meters. All right, and that equals, so the span is 14. Okay, so we've got 14 meters multiplied by VB, so the reaction on the right. Okay, so that equals, this one would be 11 Newton meters plus 120 Newton meters plus 156 Newton meters equals again the minus, because on the right is the anti-clockwise, isn't it? VB. Don't forget we're working out VA, or the moments around A, or left. We're working the right reaction, so we start on the left. And then what this looks like then is if we can just bring this over to here. So we've got VB equals 287 divided by obviously the span. That equals 20.5 newtons. Okay, so that's VB, that's the right reaction, the anti-clockwise moments around MB, or the vertical force B, or the right reaction. That's what we've just worked out. So VB equals 20.5 newtons, and then we can say VA, or reaction left, or moment over VA, vertical force A, is equal to 47, because that's the total sum of forces, minus VB, which we know is 20.5 newtons. So therefore VA equals 26.5 newtons, and then if we add 20.5 newtons plus 26.5 newtons, they equal 47 newtons, which is the total sum of forces, brackets, equilibrium, just about get that in there at the bottom. And that's why we say this here, the total sum of forces vertical equals 0, because the total sum of forces, vertical forces, equal the total sum of the forces down. So therefore it's 0, it's an equilibrium.